In our final lesson for this part of Chapter 4, we're going to jump all the way up to Lesson 4.10, Write Quadratic Functions and Models. We're not actually graphing in this lesson, but we're going to use key features to write equations of quadratic functions. And we're only going to work with vertex form and intercept form. If you know the vertex, if that's given information for you, substitute the h and the k in for h and k in the vertex form for a quadratic function. Otherwise, if you know the x-intercepts, use those values and plug them into the intercept form. So the first thing you have to do is just figure out what form you're going to work with and plug in those key features. The other important part on creating a quadratic function is determining your a value. We'll always be given an additional point, and we'll plug x and y into our equation with the other given information and use that to determine our a value. Once we know our a value, then we can finally write the equation for that quadratic function. Let's take a look at the examples on the right. Use the given information to write the equation of a quadratic function. In example A, it says we're given the vertex as 1, 6. That's going to be our h and our k value. If we start off with that template for vertex form, y equals a times x minus h squared plus k. If we substitute our values in for h and k, we're going to have y equals a times x minus 1 squared plus 6. That's substituting in the h and the k. Then we have an additional point, and the point that's given we'll use for x and y, and that will help us calculate our a value. So that 2 is actually going to go on the left, and negative 1 is going to go in the parenthesis. Everything else will stay the same. This will allow us to solve for a, but we really have to be careful with our order of operations. Negative 1 minus 1 is negative 2. And negative 2 squared would be 4. That means we have 4a plus 6. Notice the 6 isn't a like term. That means we need to move it over. I'll subtract 6 from each side, and we get negative 4 equals 4a. To get a by itself, simply divide each side by 4, and a will equal negative 1. Once you know your a value, we're just going to go ahead and take that and substitute it into our equation where we've already plugged in the h and the k. So we're going to plug in our a value right here. This will give us y equals negative 1, or you can just write a negative if you want, x minus 1 squared plus 6. There's the equation of a quadratic function in vertex form that has a vertex of 1, 6, and goes through the point negative 1, 2. For our next example, we're given the x-intercepts, negative 2 and negative 6. Those are our p and q values. Using intercept form, we start with the template y equals a times x minus p and x minus q. So watch this, everybody. If we plug in negative 2 and negative 6, we end up with a double negative. And we'll just make that positive in the next row. Like this. X plus 2 and x plus 6. So there's that first step. Again, we're given a point, negative 3, negative 4, to substitute in for x and y, and this will help us determine our a value. Plugging in negative 4 on the left, and then we have to plug in negative 3 for both x's on the right, and then leave everything else the same. So we have negative 3 plus 2 times negative 3 plus 6. There's a 2 right there. Oh boy, there we go, that's a 2. And then simplify. Keep our a on the outside. Negative 3 plus 2 is negative 1, and negative 3 plus 6 is positive 3. Negative 1 times negative 3 is negative 1 times 3 is negative 3. And to get a by itself, we'll divide each side by negative 3. Try to get that to squeeze in there. Just going to go way up here. And if I have a equals negative 4 over negative 3, that will simplify to positive 4/3. Now, once we know our a value, all we're going to do, everybody, is just substitute it in the same spot where we plugged in our p and our q. So this equation in intercept form would be y equals 4/3 times x plus 2 and x plus 6. There's your equation. All right, now it's your turn. Try examples C and D simply by modeling the process that we did up above. If you feel confident that you've created both those equations, then press play and we'll go on to those last examples. Okay, everybody, let's see how you did. For part C, the vertex was 2, 1, and it goes through the point 4, negative 2. I plugged in what I knew for h and k and then used an additional point to solve for my a value, and I got an a value this time of negative 3/4. And then plugging it back into the equation, y equals negative 3/4 times x minus 2 squared plus 1. And there would be the equation of that quadratic function. Over on the right, the last example D with x-intercepts negative 1 and positive 4. Notice what happens in the parentheses, everybody. If it's negative 1 as an x-intercept, it automatically is plus 1 in the parenthesis. And if it's 4 as the intercept, it's negative 4 in the parenthesis. Again, that's that rule. Anything with x will always translate in the opposite direction. Plugging in 2 for x and 4 for y gave me an a value of negative 2/3. Finally, I plugged that back in that step where I already put in the intercepts. Y equals negative 2/3 times x plus 1 times x minus 4. All right, on the back, let's look at a different interpretation of this. Our last two examples have us interpreting a graph in order to write the equation. So really, we're going to do the same things we did on the front. We just have to interpret the parts that we need. It's pretty easy to tell what they are, too. In that first example for part E, it says the vertex right here is negative 1, is 1, negative 2. So that's going to indicate vertex form. Y equals a times x minus h, which would be x minus 1 squared, plus k, which is technically minus 2. Now, also on the graph, I notice another coordinate that they give us to work with, 3, 2. And that we can substitute in for x and y. If we substitute in 2 for y on that the left-hand side, and then 3 for x on the right-hand side, now it's just order of operations. So let's clean this up to get a by itself. 3 minus 1 is 2, and 2 squared is 4. So this becomes 4a minus 2. To move that negative 2 over, we're going to add it to the left-hand side, and that gives us positive 4 is equal to positive 4a. To isolate your a coefficient, divide both sides by 4, a will simply equal 1. Now, we can substitute that in up here at the top, and you can either write the 1 in or just leave it as y equals x minus 1 squared minus 2. That would be the equation that models the parabola in example example E. Wow, I was looking at F when I said that. For example E. All right, let's move on to F and be done. Taking a look at the graph of the parabola for part F, notice that 3, 2 up here on that right-hand side isn't the vertex. So if I look at the x-axis, I can tell it crosses on the left side at negative 1 and the right side at 4. We can utilize those values as P and Q, otherwise known as our x-intercepts, meaning we would use intercept form. Y equals a times x minus P times x minus Q. And I'm just going to simplify that first parenthesis to be x plus 1. Now, the 3 and the 2 are going to be helpful for us. We can use those values and substitute x and y. If I substitute 2 on the left for y and 3 on the right for x, all we need to do here is simplify. 2 on the left still. 3 plus 1 is 4, and 3 minus 4 is negative 1. That would give us negative 4a. To get a by itself, if we move that -4 over, we're going to divide, and a would equal, I don't know why I just wrote that, hang tight. All right, back on. A would equal -1/2 if we simplify that fraction. And I'm simply going to put that up here. Y equals -1/2 times x plus 1 times x minus 4. And that's how you can navigate a graph to determine the parts you need for your quadratic function. And this is our final lesson for this part of Chapter 4, Lesson 4.10.